There we go. I was doing so well today with recording. So next, future value. This is the future value formula for simple interest. Future value determines not just what your simple interest is, but how much you will have at the end of 5 years, or how much you will pay in total for a 3-year loan. We usually use the letter A to represent future value. This formula is the same as this. It is the same as taking our principal and then adding the interest earned or the interest paid. That's supposed to be an I, not a J. Let me fix that. To it. So you might see either, so you could do this as 2 steps or as 1 step, basically. Sometimes it'll be easier to do one way or another in a certain problem. So this future value formula for simple interest is the future value A is the principal times, this is the number 1, plus interest rate times time in years. P is also sometimes referred to as the present value. So P is the principal, but it's also sometimes called the present value. You might sometimes see PV used instead of P, specifically for that. You also might sometimes see FV used for future value instead of A. Both of these formulas that you see on your screen right now are logically equivalent. They will give you the same answer. The bottom one is more concise, because what the first one really is saying is you have to find I first. So the first one is really A equals P plus, and remember I is principal times rate times time. And this simplifies to this. So this formula that I'm boxing right now lets you do things basically in 1 step as opposed to 2 steps, which usually is a good thing. Sometimes you'll want to use this approach because sometimes a problem will ask you 2 things. It will ask you how much interest did you pay, how much will you repay altogether, how much interest did you earn, how much is in your bank account now. And in a case like that, you have to, when it asks you to find the interest, this formula might actually save you time, or it might not. Just depends how quickly you work at it, I guess. So let's look at future value here. Here's another thing I should mention. You will see problems that aren't in years. You will occasionally see problems like this one that are in months. But T in our formulas for interest, T is always in years. So if you see something other than years, you have to convert it to years. If it's months, you convert it to years by putting it over 12, because 3 months is 3/12 of a year. 5 months would be 5/12 of a year. 13 months would be 13/12 of a year, and so on. So if the problem is in months, start by putting it over 12. If it's in weeks, put it over 52, but we'll talk more about weeks later on. So what we have here is we have the variable P, that is $1,060. We have R, which as a decimal is 0.065, and we have T. T is 3/12, which simplifies to 1/4 or 0.25. We then plug those values into the future value formula. We have to follow order of operations. So we do R times T first. We then add 1 to our answer, and we then multiply that by 1,060. So we do inside parentheses first, and in the parentheses first we multiply, and then we add. That takes care of the parentheses, and then we multiply whatever that number is times, in this case, 1,060. When we round to the nearest cent, the future value of our loan would be $1,077.23. For your final exam for this course, you will be allowed to use a page of notes front and back on the exam. I strongly recommend that you include some formulas on that page, including this formula. You might want also to include the simple interest formula, I equals PRT, but I would strongly recommend you put this formula on it and that you label what the formula is, that you say, oh, this is the simple interest future value formula. We're going to use these letters a lot in this chapter, PRT, but if you're worried you aren't going to remember them, make a note in your notes. Say R is interest rate. It's always a decimal. T is time. It's always in years. P is principal or present value. A is future value. If you need to put it in notes, put it in the notes that you use. I'm not sure you'll need all of that. It depends on the person. Some people don't need the formulas at all. Other people don't need, they know that R is interest rate. And other people forget that on the test. So it's really, you know yourself what will work for you. We can use this formula, A equals P times 1 plus RT, to also solve for R or T. We can solve for any letter in a formula. We did that back in chapter 6. And so here, we are going to determine a simple interest rate. We're going to find R. You borrow $2,500 from a friend, and you promise to pay them back $2,655 in 6 months. What simple interest rate are you charged or are you paying? And so we're going to use that formula. We are going to use A equals P times 1 plus RT. We know what A is. Here, we also know what P is. We don't know what R is, but we know what T is. 6 months, that would be 6 over 12 or 1/2 or 0.5. So we'll do 0.5, I guess. So the first step here is we have to distribute. And change color here a little bit. So we're going to start by distributing. Whoops, no, Carl. Pen, ink color, change, there we go. We're going to distribute 2,500 times 1, and then 2,500 times 0.5 R. And so we'll have 2,655. 2,500 times 1 is 2,500. 2,500 times 0.5 or 1/2 R is 1,250 R. So even though we normally solve for X instead of R, this should look very similar to things you did back in chapter 6. All it is a different variable. We're going to solve for R, and that's what we do here. So this was the thing first up, what we already did on the last slide, this and this. We then subtract 2,500 from each side. We get 155 equals 1,250 R. Divide both sides by 1,250. Now we get R is 0.124. When you're being asked what the interest rate is for a problem, you always write it as a percent. So that is 12.4%. That's your answer. That's how much interest you are paying your friend. Any questions? All right, we are going to now do a couple of examples. We're going to look at some different time amounts, and we're going to learn about present value. So we're going to move over here. Move over here. Whoops. The first thing I want to do is talk about present value. We're going to do this a lot more when it comes to compound interest, but I want to talk about it a little bit for simple interest. A present value problem basically asks you, it's usually for an investment or a deposit. How much do you need to deposit today to have a certain amount of money in the future? So for example, I, for some reason, need $600 in 5 years' time. My savings account pays, we'll make it higher than it really would be, 4.8% simple interest. How much money, and I'm sorry you can't read my handwriting right now, I know because I'm writing quickly, do I need to deposit today? This is a very common type of problem. Sometimes they'll give you a purpose like, oh, you're saving money for a mortgage, you're saving money for a new car, you're saving money for your kids' college tuition. You need X number of dollars 5 years from now, 10 years from now, 20 years from now, 2 months from now. What should you put in the bank today if you know you're going to get this same amount of interest? Maybe it'll be a savings account, maybe it'll be a certificate of deposit or a CD, maybe it'll be something else. That stuff really doesn't matter. The situation doesn't matter. What matters is the numbers. So what do we know? Well, we know what our future value has to be. We know that our future value is going to be $600. We know our time is going to be 5 years, and we know our interest rate is going to be 0.048 for 4.8%. So what we're going to do then is we're going to plug these in to our future value formula for simple interest, and we're going to solve for P. So $600 equals P times 1 plus 0.048 times 5. So for a present value problem, think of present value as beginning value or starting value. So here, how much do I have to start with? How much do I have to deposit today to have the amount I want in the time frame I want? We have to follow order of operations here, and I'm going to do this on the calculator, but I'm going to first talk about what order I'm going to do it in. First we do in parentheses, and the first thing we're going to do is multiply. We're going to multiply 0.48 times 5. And then to that, we're going to add 1. So let's do that. .048 times 5 is 0.24 plus 1. So 1.24. So we have 600 equals P times 1.24. So I need to get P by itself. So to get P by itself, I divide both sides by its coefficient, which here is 1.24. So P is going to equal 600 divided by 1.24. 600 divided by 1.24. And we're going to round this. Now here we have unique, I'm glad this came out like this. For present value problems, do not round to the nearest cent. Always round up. For present value problems, Do not round to the nearest cent. Always round up. We do this because we want to make sure we actually have $600. If we don't round up, we might end up with $599.99. So you're trying to figure out how much money you should deposit today. Always round up. So normally we would just say, oh, this is $483.87 because it's 0.8709. We are going to round this up to $483.88. We wouldn't normally do that, but we will here because it's a present value problem. And for a present value problem only, we always round up. And I say always, I really mean more the convention is that we typically round up in those situations. I am telling you to round up when it's a present value problem. I can tell who listens and doesn't when I see the homework. Round up for present value. Don't for future value. Don't if you're solving for A. But if you're solving for P, round your answer up. Otherwise, round it to the nearest cent if you're solving for A. But if you're solving for P, go up a cent. Unless you get an exact answer. Like if your exact answer was $472.53, and that was it. It was like there was no other decimal. Then keep it what it is. But it was 0.531, round up. 0.5301, round up. Round up unless you only have 2 decimals in your answer, which you won't normally be in that situation. So present value. And then I want to talk about the banker's rule. I'm not sure it's a plural possessive or not. I'll say that it is. Your book talks about this in section 8.3. And I want to remind you, it is important that you actually read your book. If you haven't been, please start. I hit the highlights and I hit what I think are the most important things for you to know. Don't get me wrong. But there are things that we just aren't going to get to in class that are still important. And if a section is assigned to you, and if I don't say, oh, you can skip that information, you really should read your book. You should work the practice problems in the book as you're reading it. One thing that's in 8.3 it's important to realize is this idea of the banker's rule. Back before there was widespread use of calculators and computers, obviously banks and other financial institutions still used formulas like these. They were allowed to do some shortcuts to make the formulas easier to work with. One of those shortcuts involved the number of days in a year. We know there are we know there's actually 365.25 days in a year. We aren't in this class going to worry about leap year. So we're going to say that there are 365 days in a year. That's a true statement. What the banker's rule did, and most banks don't follow it anymore because there are widespread computers and calculators and things like that, is to make calculations easier. The regulations used to say that a bank could assume there were 360 days in a year. And because of this, you will still sometimes see problems, including in your textbook in this chapter, where it will tell you, assume there are 360 days in a year. There was a similar, I think, it might not have been as official as this one, but it's similar for weeks. We know there are 52 weeks in a year. That's a true statement. Sometimes a problem will tell you, assume there are 50 weeks in a year. That's to make the computation easier if you're doing things by hand. But in this class, you're using a calculator. You have to, in fact, a calculator is required for this class. So what we're going to do is we're going to compromise. When you see in your textbook or in the instructions for a problem, assume there are 360 days in a year or assume there are 50 weeks in a year, then that's what you're going to assume. Otherwise, you are going to follow the truth. You are going to say that there are 365 days in a year or there are 52 weeks in a year. So if the directions say assume 360 days, for example, then assume 360 days. If the instructions don't say that, then don't. Then say, oh, then there are 365 days in a year. Do not say there are 365 and a quarter days. Even though that's true, that's not true for interest. We aren't going to worry about how to deal with leap year in this class. And this relates to the final thing I want to talk about with simple interest, which are some of those other time periods. And we're going to see this for compound interest also. I borrowed money. Horrible handwriting today. I apologize. From a friend. I borrowed $90 for 3 months at 8.27% interest. How much will I owe my friend? So here we'll use the future value formula for simple interest. Because how much will future, right? Will, future tense. A equals P times 1 plus RT. And so A is what we're trying to solve for. P is the amount we borrowed. Interest rate, 0.0827, and then time. Time is always in years. In this problem, we say it's 3 months. 3 months is 3/12 of a year. We could simplify 3/12 to 0.25 or to 1/4. You don't have to, unless a problem asks you. Like some of the multiple choice problems you're going to see might ask you to simplify. So you should be able to do it, but you don't have to for something like this. So what we're going to do is we're going to take 0.0827 and multiply it by 3/12. That's the first thing we're going to do. Then we're going to add 1 to our answer. And then we're going to multiply that answer by 90. 1, 2, 3. So let's do that. So 0.0827 times 3 divided by 12. And we get this. I'm glad we got a little bit of a decimal here. This gives me a chance to talk about this. Do not round intermediate steps if you can help it. You need to usually round your final answer. Remember, we round it typically for future value, near a cent. For present value, we round up a cent. In other cases, we round to the nearest hundredth or whatever the problem tells us to do. Don't round the intermediate steps. Don't say, oh, this is about 0.02. Don't say this is about 0.021. You will get the wrong answer. As much as possible, what you should do is just let your calculator handle it. If you have to write it down, keep at least 6 decimal places. Now, this number happens to actually have just that amount. That's a coincidence, but I would say at least 6 decimal places for what we're doing in this class. Your answer will be more accurate if you do that. I'm not going to guarantee it's going to be right even then, but it will probably be right. as much as possible, what you want to do in this situation is let your calculator handle it. And so rather than rounding this, for example, that's why I numbered those steps ahead of time. I know I'm going to add 1 to this answer. So I can just do that. Plus 1 equals. And now I know I'm going to multiply my answer by 90. That's why I wrote that 3 in a circle by that. Times 90. And now I can round to the nearest cent, because this is future value. I will owe $91.86. A is approximately $91.86. That is how much I will owe my friend 3 months from now. And if I don't pay her back, I can expect to have my kneecaps broken. So I better start saving. Similarly, you will see occasionally a problem where rather than months, you have days. Let's say that I'm lending money to a friend instead of borrowing from one. I lend my buddy $120. He'll repay me with 9% interest in 40 days. How much will he repay me altogether or in total? So now instead of months, I have days. Everything else though is okay. So I lend him 120 bucks. So P equals 120. Interest rate 9%, R equals 0.09. The tricky part is time. It's going to be a fraction. So days. This is going to be the number of days he borrows the money for over the number of days in a year. There are 365 days in a year. We are not assuming 360. So it doesn't say that on the problem. So my time is going to be a fraction. It's going to be 40 over 365. So I can plug these values into my formula. Future value formula for simple interest. A equals P times 1 plus RT. So A equals 120. So I'll make that a real 1 too. 120 times 1 plus 0.09 times 40 over 365. I could certainly simplify 40 and 365. 5 goes into both of them, for example, but there's no real need to. We're going to use the calculator. And so again, I'm going to do this 1, 2, 3. Multiply, then add, then multiply. So 0.09 times 40 divided by 365 equals. So notice I get a really long, really small number. That's good. I'm going to now add 1 to that. And now I'm going to multiply it by 120. Now my answer here, I can round to the nearest cent, which is going to be 18 cents. So $121.18 approximately. So my friend is going to pay me a total of $1.18 of interest. So clearly, I am not going to get rich loaning money to my friends. I clearly need to get friends willing to pay higher amounts of interest. Please make sure you read the problems carefully so that you know, are they asking you how much will he repay me or how much interest will he pay me? The interest here would be this number minus 120, for example. So he would pay me $1.18 in interest. Read the problem carefully. Something just completely, I was going to say something that completely left my mind about this. Oh, calculator. I want to do this first. I can't remember which one it was that we saw this. There was a problem that I had this morning that just worked out really nicely. And I was thinking, oh, that's good. And I think it's gone now, which is unfortunate. Let me see if I still have it, actually, if I deleted it during statistics. I deleted it, I bet, for statistics, unless it's here. Maybe it's here still. Hold on a second. Was it 1112? No. Was it one of those? We're not going to go that far today. Okay, I'm going to do one more thing and then we'll move on. If I can't find this. 0.2. Nope. Okay. When you will sometimes get a very small number in your calculator. So let me try to make one of those. There. Notice this number. 4.9997, blah, blah, blah. And then look at this end, E minus 6. A common mistake people make when they see a number like this is they just look at the left-hand part right here, which you can't see me moving my mouse there. We look at the left-hand part right here, and they might say something like, oh, look, this is going to be about 5. And if you say this is 5, that's a reasonable, and that's not reasonable, it's understandable. But your answer is going to be way wrong because of this final part here. E to the negative, this is E minus 6. This is not, well, we'll talk about what E is later. This is not that E. This is scientific notation. This is how the calculator writes times 10 to the negative 6. So this number will make it, let me go back to our class here so I don't confuse myself more when I start the other class. So this number, 4.999725, 4.9999725, and then there's a bunch more digits, and then we see E minus 6. This is the same. Remember when we did scientific notation back in chapter 5? This is the same as this. That E is how the calculator represents times 10. These two things are equivalent. And so what this means is that this number is really this. It's 0.12345699725. So it's actually a very, very small number. You might run across that. One of the example problems that I just sort of made up and was doing with one of my other classes this morning, we ran across this issue, and I was glad we did because it reminded me of it. You'll see it in other classes too. I had a student in a stats class, for example, that was confused about a problem because on their calculator, they got an answer like, not this one, but like this one, like Well, that can't be right because this has to be less than 1, and this is almost 5. And it's only because they didn't look at the end here. Or they chose to ignore the end there. Either way. So when you see something like this, recognize you're dealing with a really, really small number. That's okay. You can deal with it. Your calculator can still work with that. If we were going to add 1 to this, I think it would let us do it. Yeah, we can add 1. And then we could go on. So, I mean, if we had to add 1, we do typically in the formulas we do for interest. 1 is part of most of those formulas. Any questions? All right, we're still a little bit behind the other sections, but not tons. We're almost back on track, I think, which is great. We today finished up 8.1. We learned about percent of increase and percent of decrease. We learned about sales tax and discounts. And then we did 8.3. We calculated simple interest. We used the future value formula to find future value, or A. We used the future value formula to calculate present value. We calculated R, interest rate. And we took a look at some different time amounts, including finding things for a certain number of months, a certain number of days, and so on. There is also homework posted for 8.3. Again, I would strongly recommend you do the sample problems before you do the homework set. And please, 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 please read the instructions for the problems, for the homework, so that you get every point that you deserve to get. So if you don't have any questions for me, I'm going to put the attendance link in the chat. Hopefully. There that is. There that is. There we go. So please complete the attendance link. If you end up watching this video later on and you need help with the first part of class that didn't get recorded, please send me an email and I will answer any questions about the end of 8.1, which is what didn't get recorded in the very start of 8.3, which is what we missed in the first part of class today. Otherwise, have a great rest of your day. I look forward to seeing you back here on Thursday. And until then, take good care, make good choices, and I'll see you later. Bye for now.